Hey guys, welcome to the channel IF 4.0. This is Ajay.
Hi all, welcome. Today we will be doing an assignment on what we have learned. So we have completed fixed resources object as of. So we have completed the videos on understanding the objects and their properties for the fixed resource. Now we are going to take up the problem statements and we are going to create that on our own, and we will be learning another major things while doing this assignment. So the assignment will play a role in brushing up our concepts which we have already learned, and we will learn some of the few concepts. So you can see I have included the model background here. One slide consists of the problem statement. We will be creating this into our model and we will be running the simulation. So this is the problem statement slide of our channel, and this is another slide where we need to do the task. The list of the task is already been entered. So come on team, we will begin the assignment. We will start modeling together. So here we have a problem statement and here we have a task to do. We will validate whether all tasks are done at the end, but we will go as per the problem statement step by step. So first I will show you how I have included this problem statement into the model background. So if you go into the toolbox, you can see in the model background I have taken a screenshot of a slide which we have prepared, and that is inserted as an image, and XYZ coordinates are set it up. Similarly we have done for tasks to do. This is page 2 of the PPT, and it has been given XYZ coordinates. As a result, they are into the model as a model background. Now let's begin with the modeling. So the first thing what the problem statement says is we need to create a source. So the source, create a source with enter arrival of 8 minutes and flow item as a cylinder with white color and part count on it as a label, and that source needs to be connected to the Q1. So let's drag the source from the fixed resource library, then we'll drag a queue, and now what we are going to do is we are going to make a connection between source and Q1, and what they have told us the enter arrival time needs to be 8 minutes. You can see it's in minutes only, so we have taken as 8 minutes here. They have told that the flow item should be cylinder, so we are going to make this as a cylinder into this, and the another thing is with the white in color and the part count on it as a label. So we have made it cylinder, and now we are going to make a part as white. So on exit we will go into the triggers now, and we will be learning the triggers into the assignments, and into the visuals we will go to set object color. When we go to set object color, the object is item, and we are going to go to the drop down and we are going to select it to white. So we are going to select as white, so color dot white. So we have done this cylinder, we have made white color, and the part count on it as 1. So whatever the cylinders are going to be produced from the sources, the label on it should be the part count, which should indicate. So what we'll do is we'll create a label on the source itself as part count first. Remember always to check on the automatically reset button and save it, so that whenever you make it reset, it is going to 0. On exit itself, what we will be doing now is we are going to increment our data label. So we are going to go to the data, then increment label, and here in the drop down if you go, we have current.labels part count. So the part count label will be incremented by 1 the moment the part is coming out. So that we have done. Now what we need to do is we need to assign this label on the part, not on the source. So now we are going to assign it on the part. So again we will go on exit trigger, we'll make this plus, we'll go to the data, we'll set the label, we'll set the label of the part as on the item same, that is part count, and here we will make this as current dot part count. So whatever the part count value is going to come here, that is going to get implemented on that part. So we will check it once whether that has been implemented. We will reset and we will run and we'll stop. Let it be running. So you can see the part count of the part is 1. I will make this model run faster. Then it's 2, 3 and so on. So we are having the part label on it and the cylinder color is white. Now we'll go to the second activity. So the Q1, we need to have the capacity of Q maximum as 10. So in the maximum container we'll put it as 10, and the strategy of it needs to be first in first out. So as it is first in first out, we need not do anything, but if it was last in first out, we need to check this in. Now what we are going to do is we are going to connect this queue to the processor. So we'll double click on the area, we'll click here, we'll get a processor, then we'll make a connection between queue and the processor. And what they have told us, change the part color to green when out from the queue and the part label with the stay time on the queue. So basically what we need to do now is to change the part color to green. So that we can do, we can go to the trigger and on exit we can change the color. Similarly we did it for the source. In visuals we'll set the color of the item to green is what has been told, and when out from the queue and the part label with stay time in the queue. Now the stay time is basically the time the part was present on the queue. So say the cylinder was present on the queue for 10 minutes, that is the stay time. It was present on the queue for 20 minutes, that is the stay time. So we need to put that as a label on the part. So what we are going to do on exit, we are going to assign 3 labels. So third is our stay time label, but 2 are in and out time. So basically what we are going to do for a queue, on entry we are going to put the in time label on the part. So we'll put this as in time, which will be assigned to the item, and the value of it would be the time. So time and the circular brackets. So we have entered on entry label to the part, and now we are going to check out another label on exit to the part, and that label will be setting out as out time. So we will have what is in time and what is out time. So out time, and the value for it similarly will be time curly brackets closed. So now we have 2 labels on the part, that is in time, and then another label on the part item, that is out time. And then on exit itself we are going to make another label on the same part, that is stay time, and the stay time would be basically will go like item dot out time minus item dot in time. So I'll make this as dot. So we have item dot out time minus item dot in time. So what we will do is we'll open this first, and then we will open the code editor of entry trigger, and we will copy this for our preventing the code error. So in time I have copied, out time of the label I have copied here, and I'll apply an OK, and I'll OK. So this is made OK. Now we have fulfilled another condition with the part label and stay time. We'll reset and check whether on the processor we are going to get these things. So if you check it, this is the first part, so it's 0 0. I'll make another queue, that is Q2 we need to prepare after processor. So just for checking purpose I will make this. So I have first cylinder, another cylinder green in color, and you can see the difference is 2. So the part came in at 8, out at 10. So the stay time from this queue was of 2 minutes. The model unit is in minutes. So once this is done, now we will be fulfilling the processor conditions. So they have told that the processor should be created with the color orange. For orange color, we'll go here and we will select it, the color, it's orange in color. Then we will go and select the process time as 10 minutes and we'll put the setup time as 2 minutes. As mentioned, the part color should turn to blue when out from the processor, and on processor part out stamp. So now what we are going to do is on exit we are going to assign the data label for the item as stamp time. Stamp time would be equal to the time when the part was left from the processor. So similarly it would be time and the curly brackets. So this would be the label on the item which will say at what time did the part left the processor. So that is the stamp time label which will be coming on the processed part. So we have assigned a label to the part out stamp, and then the part color should turn to blue. So that is pending. So on exit we will change the color, that is visual, of the object, that is item, to blue, and we have made that as blue. And then what they have told is create a queue input to the processor, output to the sink. So Q2 will be connected to the sink. So I've put it a sink here, and they have told that the parts when coming into the queue should be horizontally. So we should have the stacking, that is horizontal line, and the capacity they have told that, and the part should leave the queue only when you have a bunch of 50 parts. So whenever you are going to have 50 parts in the queue, that 50 part slot should be sent ahead. Then it should wait for another 15 parts, then it should go ahead. So it should go in a lot of 50-50 out from the Q2 to the sink, and the part should be yellow in color on entry. So whenever a part is going to enter this, so we are going to put an entry trigger. We need to set the visual of the part to yellow, so we will make this as color as yellow. So we will validate first whether these things are done good. So we haven't applied this 50 parts condition yet, so it's directly going from Q2 to the sink. But you can see, but that's the reason we are not able to see the part on the queue yellow in color. But you can see we need to have white color here, then we needed to have a green color when going out from the queue, and then on the processors all conditions satisfied, it's having 210. Then we are going to have a blue color when it's coming out, and create a queue, and the part should be yellow in color on entry to the queue. So what we will do is, so this when blue color should turn to blue when out from the processor, when out from the processor blue, when into the queue yellow, that means we are not going to see that change in the color, it would be directly green to yellow. Now what we will do is we will do perform batching thing, because what it has been told us, we need to have 50 parts of batching done. So we are going to make it as reset, and we are going to run. So if you see now, I will make this model faster. So we are going to have this parts out only when we have 50 parts on the queue. So when we are going to have the 50 parts on the queue, it should go to sync, or else it should not. So you can see it is going in the horizontal line, and it has been waiting till it is 50. So I will make this more faster, and when it's 50, it's out. So you can see input to the sync is 50, output from the it is 50. So we have successfully created a model, we have created a logic. Now we need to create the dashboards to understand. So we will reset this, we'll go to the dashboard, we'll add a blank dashboard, and we will create the state pie chart for the processor. We'll use another output bar chart for the processors. So throughput and state graphs were required. So I will select processor. I'll click on the throughput graph. I'll click on this sampler, and again I'll click on the processor. So in both of the state and the throughput dashboard graphs, we have selected processor. Now what we're going to do is we're going to reset, and we're going to check whether it is showing. Yes, and it is showing that it is 100% utilized, and you can see 82% it is processing, 18 to 17% it is under setup, and this is the throughput from the processor. Now we will go to the another thing which has been told: create maximum stay time graph for Q2. So stay time will go stay time graph for the Q2 basically, and that is basically a line graph, and we have selected a bar graph. So I'll delete this, go to the stay time, we'll go to the line chart because we need to have a line graph. Go to the sampler, we'll select this Q2 and we'll reset. Then we need to create a throughput per day graph for a line, that is total production line which we have. So I'll go into the output per hour graph. We'll have the tabular graph here. I'll change this to output per day. If I'll reset this, it's output per day, and the interval should be 1 day as it is told per day. And we are going to go to the sampler, and we will select same. We will select the sync because sync is our end of the line, and then we will understand what is the end of the line throughput. Then we need to identify the bottleneck at the end. So we have created the state and throughput graph for the processor, maximum stay time graph for the Q2, and we have created the throughput per day graph for the whole production line which we have created. So I'll reset this and I'll run this. Oh, sorry, this output per day, because sync does not have an output, we need to check on this buffer. So that is Q2. So we'll assign that there and we'll have a run. So I'll make this faster, slow. So you can see we are having this throughput from the processor thing 90 after 1088 minutes. If I make this faster, you can see the graphs changing, and you can see here the stay time of the queue. So the stay time of the queue, like the part stays on the queue, is almost 600 minutes. So basically we have taken for the Q2. You can check this here. Maximum stay time is for 588 minutes. That's almost 600. And the output per day, you can see here, it's an averaging, like it will say you what is the output per day of this production line. So it's almost 100 and it's reducing, and it will come to a one state when the model is fully stabilized. So it is almost 108 to 100 parts per day. So we have completed all the tasks to do. We created model logic, the dashboard graphs. We have created this model, learned about triggers, we learned about the dashboards, and this is the whole overview, beautiful overview of the model. You can see along with the details of the graphs, and these are the logic of the 50 it's going, and these are the beautiful graphs coming out. You can go up, you can come down, you can add multiple graphs as per requirement, and this is how the model looks as per. So this is our assignment 1, which consists for the fixed resource. We'll come with another assignment same for fixed resource, but we will be consisting combiners, separators, multiprocessors in our assignment 2, and somewhat more trickier triggers we will be using, learning more new things. And this is our simulated model for assignment 1. Let me know in comments how you feel it. Any queries, any questions, you can add in the comment. We can also go live if it is required. All your doubts and questions will be answered. Just post it into the comments. Thank you for your support and love, and we will continue learning Flexsim